Okay, so welcome back to another video. So in today's video we have this is the third algebra problem that involves a lot of a one-digit number involving with a bunch of radical symbols as well. So let's see if I can read this in one try. So we have the 7th root of 7 to the power, the 7th root of 7 to the power 1 divided by the 7th root of 7 to the power 7, and then divided by 7 to the power the negative 7th root of 7, and then to the power the 7th root of 7 multiplied with 7 times negative 7th root of 7, and then to the power the negative 7th root of 7. Nailed it. So I just want to apologize in advance for the lack of uploads lately. I was mainly just preoccupied in my master thesis research, so this took up a lot of my time, but now that that's out of the way, I can actually have some free time to actually upload more, and also uploading on a consistent schedule with every 2 days. So let's hope that I can keep it this way. But anyway, jumping into here, there's a lot of 7's and a lot of radical symbols. So this is like from those 2 videos I did with a bunch of 3's and then one with the bunch of radical symbols as well. But again, just it may look complex, but it's actually just a pretty simple algebra problem from here. So if we rewrite some things, then it'll be a piece of cake from here. Okay, so just like I mentioned, let's actually rewrite some things because of the exponent. So we have that an exponent to the power exponent to a power exponent. Really, you use your rules, we can actually, this is all just a product of exponents with the base. So now we can rewrite the numerator. So we get that this is the 7th root of 7, and then to the power the okay, so the 7th root of 7, and then multiply this with 1 divided by the 7th root of 7, and then multiply by 7. Okay, and how about we rewrite the denominator as well, since we have a product of exponents. So this, we have 7, and then to the power, let's see, so this is so I can just keep this the way it is. So this is the negative 7th root of 7, then multiply with square root of 7 to the 7. Okay, and then that's also being multiplied with 7. Then this is the negative, so negative times okay, the same thing as before. So the negative times the negative 1 times the 7th root of 7, and then multiply by the negative 7th root of 7. Okay, so now with this, now we can actually do some multiplication with our exponents. Okay, so when we multiply our products here, so that means that we have that, you see the 7th root of 7's numerator and denominator cancel, so we're left with is just the exponent is just 7, so the 7th root of 7 to the power 7, and then let's actually rewrite the exponents from here. Okay, so this means I have this will be 7, and then the base here is 7, and so they share the same base and they have the same different exponents. But what that means is that I can actually add the exponents up our base 7 from over here. So that means we have this is negative 1 over 7 and plus 1 over 7. Okay, and then over here we multiply here 7, just do the same thing as before. So this is 7, and then this is negative. So actually this is supposed to be a negative 7 over here. So negative 7, and then to the power 1 divided by 7, and then base 7 here with the exponent negative 1 over 7, so this will be minus 1 over 7. And so when I rewrite some stuff from the numerator, this is the base 7 to the power 1 over 7, then multiplied by 7. Okay, and then from here, this is 7 to the power 7, negative 1 over 7 plus 1 over 7, that's 0. Then multiply this with 7 to the negative 7, 1 over 7 minus 1 over 7 is 0. That means from the the denominator. So this is just 7 times 1, then multiplied by 7 times, let's see, that's supposed to be -1, okay? And then multiply here, 1 over 7 times 7 is just 1, so this is just 7 to the 1. And then when we combine the terms, we have 7 to the first power times 7 to the negative first. You just combine those, you're just gonna get that it's just 1 on the denominator. And so we have that our final answer is just 7. And I think I found the title of this video. I'm just gonna call it Lucky 7's with however many question marks I feel like I wanna add. So yeah. All right, now that's pretty cool if you ask me.